All right, so with permission, here's Natalie's 12th problem. What's actually nice about this question is it could have started out even more difficult. It could have started out as x squared plus 5x over x squared minus 3x minus 18 is greater than or equal to 0. It could have been even messier than that because there could have been a non-zero number over here that you would have had to like subtract over and then clean up. Bless you. So for example, it could have been something like x squared over x squared minus 3x. You don't need to write this down, especially since I'm recording it, is greater than or equal to negative 5x over x squared minus 3x minus 18. Now I'm going to erase all this stuff, but the point is it could have started out like this. You would have had to add that piece over. That would have added the tops, but the bottom's the same. So it's just, adding fractions. Combine the tops over a common denominator. And then even in this form, you would have had to factor it to get this. So a quick heads up that these are relatively easy problems, but when you get into pre-calculus, you'll see some of these where they start out more like what I had down here, or maybe they'll start out like this and you have to at least factor it first. All right, so nice thing is it already started in factored form. They say solve. So what we're going to look for this time is not just the boundaries where they're equal to 0, but we're going to also look for the boundaries where you cannot even be defined, where the number doesn't even, where a number can't even be plugged in. It doesn't exist. So first set that we're going to look for is where x times x plus 5 over x minus 6 times x plus 3 on bottom is equal to 0. Well, how do you solve that? I'm reaching back into your chapter 7 memory. Yes, your fraction bust, which is ultimately the same thing as just cross product. So I'm going to write it as a cross product, but you're right. You'd fraction bust, you'd multiply the common denominator on both sides. That is the common denominator, x minus 6, x plus 3. But that's just the same thing as then cross product, which is just going to be x times x plus 5 equals 0, right? So what we're finding out is that the places where they're equal is going to come from the numerator position. So they're equal when x is equal to 0 itself, or when x is equal to what? Negative 5. Good call. So I'm going to start imagining the number line right here. And I've got 0 and 1, 2, 3, 4, 5, negative 5. Now, I'm going to go ahead and just put a solid dot down right away, because are we going to allow equality in this question? Yeah, that means we're going to allow the spots where they actually intersect, or intersect. Those two. Those are called the x-intercepts. Okay, then the next thing that I have to question myself about is, where can there not be an answer at all on this question? Where is this entire rational expression undefined? What makes a fraction undefined? What about 0? 0 as the denominator would make it undefined. So what we have to do is we have to set this denominator, which is an entire product of x minus 6 times x plus 3, equal to 0, and then we got to throw those out. So we're trying to say, when are they equal to 0? Well, they're equal to 0 when x itself is equal to 6, or when x itself is equal to negative 3, right? So what we find here is that we don't want to use those. Those would be asymptotes. I know we haven't really used that word before, but it's fair to give it to you. Asymptotes, if I can spell it. Asymptotes. And they'll technically be vertical asymptotes. So remember that the equation of a horizontal line is in the form y equals a number, and the equation of a vertical line is in the form x equals a number. Let me scoot back a little bit. These would give us an asymptote at x equals -3, meaning we just can't have that. That's what we want to have clear in our mind. And x equals +6. So you essentially think of the line x equals -3, but it's a dashed line that you can't ever go through, and the line x equals +6, and it's a dashed line we can't ever use. So how many regions do we have this time to test? Because previously, on like that problem right there, we had 3 regions. On an earlier problem, we had 2 regions and 4. How many regions here? We actually get 1 region right here we have to test. And between where we can have an intercept and where we can't even plug in a value, we get another region. So we get another 1, 2, 3, 4, 5. We actually get 5 regions to test. Time to start picking some numbers we're going to plug in. Okay, just because I want to keep the numbers close to the screen, I'll go ahead and move this out of our way. And let's test. You tell me what you want to test. Something in region A. And get your calculators ready. What'd you say, -6? Okay, let's test x equals -6 then. I'll show you how it works so that you're clear on what I'm asking from you. You've got -6 in there, -6 in there. And what are we hoping for it to turn out to be? Positive, negative, what? Positive, right, greater than 0. We've already taken care of where it's equal to 0, so we're hoping that it's going to be positive. Please tell me what number you got when you worked it out. Now I have a pretty good eye, so I think I can tell. You got a negative number right here. Then you've got a negative number right here, because this is the 6 is bigger, right, than the 5. So you got another negative number right here. So on top you got positive. Now if the bottom turns out to be negative, then the entire thing will be negative, right? So down here you got a negative number again, and right here you got a negative number again. Wait a minute, that means that we ended up with a positive on bottom. Positive on top, positive on bottom, what do we get? Positive. Darby, did you have the number? Because I saw you looking at your calculator.
0.167.
Yeah, because that's going to be 1/6, which is going to be 0.167. I don't care how small of a positive number it is. All I care is that it is a positive number. Because we're trying to see when is it greater than or equal to 0. That is definitely greater than or equal to 0. So we say true right there, right? I'm going to start highlighting my true regions right now. So it's true from everything up to that point. What about on the left? Is it still going to be true the more negative we go? Yeah, absolutely. How about at the actual boundary? Well, that's where it's equal, so we're going to include the boundary. Does that make sense about the including part? I'm only seeing some slight, oh, okay, I'm seeing full head nods now. I understand.
That was just greater than, like not greater than equal to, it would be a parenthesis.
It would be a parenthesis, good call. If this did not have the equals right here, then this would be a parenthesis. But because we're allowed to be equal, we already put a solid dot there, then we use a bracket. Okay, see how I put all this junk down here where I just kind of blurred my eyes and said, is it positive, is it negative, blah, 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 does it turn out to be positive altogether? That's kind of how you can approach this, at least in the extremes. In the middle, you need to be a little bit more particular, right? Well, I guess you don't really have to. Let's do the next one. So I want to test B. Do you think it's going to work or not work? Our typical pattern has been work, not work, work, not work. You know, true, false, and so on. I think that it is not going to work. So give me a number that's in this B region. -4, right. It's really, if we're going with integers, it's really our only pick. Okay, then let's plug -4 in everywhere. I want someone to actually be working out the entire number, even though I'm trying to show you a method to go faster. So as you're working out the actual number, I'm going to just show you the way I blur my lines. This is a negative number. This, because the 5 is bigger than the 4, is going to be a positive number. So we have a negative on top so far. Then we've got a negative number here. Then we've got another negative number here. So overall, I've got a negative number over a positive number. It means I'm going to turn out to be negative, but can you tell me the exact number? -4 over +10, which is negative what? 2/5, right? You can say that. Or you can just say -4/10. -4/10, which is greater than or equal to 0? No, it's not. That's false. Not surprising that it doesn't work in here. Okay, and this is the process. I know it's long, it's tedious. What's the next one you'd want to check? I'd probably just check -1 next. Why not -3? Is that what you asked? Why not -3? Oh, good. Same answer, right? At this point, we're not going to check -3 because we've already determined what is happening there. That's a no solution. Not no solution. That's an undefined value, right? And 0, similarly, we've already found out what's going to happen there. That's an actual solution. So you don't want to check anything where you already know stuff about. You want to check where you don't know. I am willing to bet that inside here, it ends up being positive, right? And we know that 0 is going to work. In fact, I'll wait for whoever is working out the answer to tell me what answer they got as I make this point. I know that 0 works, so that's going to be a closed bracket, but what do I do here at the x equals -3 part? Can I have a bracket there? Why do I have to have a parenthesis? Right, that creates undefined values, so I can't actually use it. So I use a parenthesis there. This makes sense the more we do it. Okay, I'm willing to bet if you guys, oh, by the way, did anyone find out a value for C when you tested x equals -1? In fact, I'll give you the numbers to test for the next ones as I'm going to make my final points. In D, I would suggest just go ahead and check 1. And in E, I would say go ahead and check +100. Keep in mind, if you've plugged this all in already once, okay, so plug it in on a nicer calculator than this, my suggestion. So I hit equals, and I ended up getting this. So that is -1 in up there. That is -1 plus 5. Then on the bottom, -1 minus 6, -1 plus 3. When I plugged it in, did I get greater than or equal to 0? Barely, right? But that's all that matters, is that when I plugged in right there, sorry, right here for C, and that was me plugging in x equals -1, I ended up getting positive. Okay, so then that's going to work. D will not work, and I'll show you D's check. I'm going to go ahead and check. Oh, sorry, I forgot to mention. 2857, blah, blah, blah. That is greater. D, I'm going to check by just going into the history, getting rid of my negative signs right there. Hit enter, and I get negative 3/10. And I'll go ahead and check this one, and I'll shade above in a second. So then make that 100. .08. .84. Okay, so D doesn't work. This one does work. It'll keep working that way forever. And what do we do right here? Why a parenthesis? Right, we can't include that. So all said and done, big ugly mess, but here's how I interpret that thing. It's from negative infinity all the way up to -5, and at that boundary we can actually include it. Then we scoop up, or we cut out the middle and pick back up at -3 over to 0, including 0. We do keep that. And we cut out that D section, scoop up, and then pick back up at +6, but don't include 6. And that is the final answer.